Hi there, welcome to lesson 1 of practical problem solving and programming. It's the second section of the IGCSE computer science course. It's based on paper 2 on practical problem solving and programming. So what we're going to do, we're just going to introduce you to paper 2 and the concept of paper 2 and how it works. So let's have a look at paper 2. So if I bring that in line so you can see it on the screen. Okay, so here is paper 2. It is examination May-June 2015. And the way the paper works is you have no more than an hour and 45 minutes. And then there is an advice here to spend no more than 40 minutes on section A, which is question 1. But you've got an hour and 45 minutes to complete the paper. The paper consists of all the topics on section 2, right the way through to databases. So let's have a quick peruse of this paper. So, as with all of the paper 2s, we get a pre-released set of tasks, which we're required to do in a lesson. So I suggest students do attempt this. You create pseudocode, so create solutions for tasks 1, 2 and 3 using pseudocode, flowcharts and Python programming. So once you've got the pre-release material and you've worked through it and you're happy with your solutions, you would attempt the exam. So question 1, it says here all variables, constants and other identifiers should have been meaningful names. So it just talks about how you created your program. So it asks you how you created your arrays, what kind of variables you use, why did you use them, etc. And whether you could improve your program by writing new arrays that you might have used. And then it looks at task 2. Where you can create a pseudocode or a programming statement or even a flowchart to attempt to answer this question. And then you move on and it talks a bit more about validation rules. It talks about pseudocode and programming statements, or pseudocode or programming statements as a use in terms of explaining a program that you made for task 3. And then moving through the exam, there's a set of pseudocodes which you have to interpret and debug. So you have to locate the errors. This is a typical question in this paper. So moving down, you've got to interpret a flowchart there and trace tables. So using the flowchart, you've got to fill in these trace tables. Trace tables, you're bound to get a question on trace tables in your section 2 paper, as is you're bound to get questions on databases as well. And obviously the pre-release material, you need to attempt those using pseudocode, flowcharts, or a programming language like Python. So moving down, you need to understand, in this paper you need to understand data types and how they work together, and then looking another question on variables, another question on pseudocode, and then move on to databases, primary key, foreign key, what are fields and how they work, etc. Queries, you need to know a little bit about queries in this paper as well, and that's it. And that is paper 2 in a nutshell for 2015 in the summer. So moving on to the lesson. So the outcomes are of this lesson to show understanding that every computer system is made up of subsystems, which in turn are made up of further subsystems. So this is a start of section 2. This is lesson 1 and 2. This lesson should take about 2 hours to complete, and then we move on to lesson 3, which is all about flowcharts and enhancing your knowledge of flowcharts. Then we'll start looking at different ways we can tackle and create algorithms, like pseudocode, etc. So we answer the question first in this lesson by answering this question: what is a computer system? Well, a computer system is a device which performs a task or solves a series of problems. It is made up of hardware, software, data communication, and people. The idea with computer systems, you need to understand the diagram of a computer system. A basic computer system will be made up of four areas, and let's create a little bit of space there. And the way it works is it would link. You would link each section with the flow of data. So when you input data, data will be processed, and at the stage of processing, you would also storage. The data would flow back and forth from the storage, and then it would be outputted from the computer system. Okay, so that is a basic computer system. Turn it off. Yeah. So subsystems. A computer system is made up of subsystems, and these subsystems are made up of further subsystems, and so on and so on, until they only actually do one task. Okay. So we're going to have a look at some top-down designs. Okay. So top-down design is an effective way of designing a computer system, and provide a specific solution for a problem. Top-down design is breaking down of the system into subsystems, and in order to show top-down design in a diagrammatic form, we would use structured diagrams, okay, to show design of systems in a hierarchical way. So here we've got a system that has been shown in a hierarchical way. Now, in the lesson, what I have shown is this video. This video is obviously the rock, and he brought out the rock app, which is a clock, which we looked at, and the idea was that it's a motivation clock. It's an alarm clock, and the alarm clock as a premise to the task. So what we need to do is think about how the alarm clock is actually structured. So we've considered the alarm app for the smartphone, and it can be divided into three subsystems. So we've got the set alarm, the check time, and the sound alarm. Those are the three main subsystems within this app. We proceeded to break down two of the three systems. So set alarm, you can break that down to set time and turn alarm off and on. And sound alarm, where you could play the sound for 2 minutes and reset your clear alarm. So as a little task, if you just pause the video and have a go at breaking down check time into further subsystems. Maybe 3 seconds just to pause the video and see what you can come up with for check time. Okay, now that you've had a little go at that task, a lot of students came out with subsystems for check. Okay, so once you've broken the check time system apart, some students in my class, they came out with a subsystem for time itself and having the time running. Another one would be comparing the time with the set time in the set alarm section in terms of what time the alarm is supposed to go off, and compare the alarm with the time that the alarm is supposed to go off, and then if it equals, then it will send a signal to the process of sounding the alarm. Once we did that, there is actually a video from Liam McQuay where he talks about the course, the Computer Science IGCSE course, and what he's done, he's created a structured diagram, for the course, where he's broken up each section into its subsystems or subtopics, and it's a good useful video in terms of understanding subsystems as a whole. Once we've done that, we looked at structured diagrams as a whole. So we're going to draw a structured diagram for cleaning teeth. So if you just pause the video and and draw a structured diagram for cleaning your teeth. Obviously include all the subsystems that you can think of, and think how you may go about cleaning teeth, what kind of processes are involved. Just think about how the design is done. It's in a hierarchical form. Okay, but just make sure you break that down. You just pause it and then have a go at that. Okay, welcome back. What you would have done is have a little discussion with your teacher on how you would go about drawing this structured diagram on cleaning your teeth. I hope you've had some good discussions out of it. So the next task is to create an encryption system. So what we need you to do is create a structured diagram for a message encryption system. So the encryption system is the idea that we're encrypting the messages from one computer to the other. So think back on how encrypted messages come about, how they work, etc. Think about the networking topics that we've done, or the encryption lessons that we've done in the past as well. So if you just pause this video at this point and then come back to me once you've done that task. Okay, so once you've done that task, have a little chat with your group or your teacher and see how well you've done. In terms of solution, Liam McQuay has gone through the solution here, so you're welcome to download the PowerPoint. Will link you straight into Liam McQuay's video. It's 2.1.1b, where he talks about a message encryption system and how he solves that particular problem. Okay, so here he's got the structured diagram. So he's got the message encryption system. With the message encryption system, there's two main parts. You've got the encrypt section and the decrypt. In the encrypt, we've got three further subsystems. We've got the input message, we've got the encrypt message subsystem, and then we've got output encrypted message. In the decrypt section, we've got input encrypted message, decrypt message process, and then output the message that has been decrypted. Okay, so that is how we would go about doing that. So further on flowcharts. Flowcharts, what are they then? Well, flowcharts show diagrammatically the steps required for a task, typically a subsystem, and the order that they are performed. So these steps that are in order are actually called algorithms. Okay, so there is a video on the next slide from Big Bang Theory, where Dr. Sheldon Cooper is attempting to make a friend. So if you play the video, and he's created this algorithm where he's trying to make a friend, and the friend is, I think it's Kripke on the phone, but there is an issue with his algorithm. He gets stuck. So if I pause the video now, and if you want to watch that clip, and then come back to me. Okay, so once you've watched that clip, you would have realised that Sheldon he did have an issue with his flowchart, where he was actually stuck in an infinite loop, where he kept on asking the question, what is it that Kripke would like to do, and Sheldon was not interested in that particular activity, and he had no, he kept on asking him what other things Kripke liked to do. However, Howard got up and solved the problem by putting a loop counter. The idea was that the loop could only go around a number of times, I think it was 6, and once he reached 6, Sheldon had to choose out the choices his least objectionable choice. Yeah, and that's how he solved that problem. So what you need to do as a class now is think about how to make a cup of tea. Here is a flow chart on how to make a cup of tea. So we've got the start, we've got the process of boiling water, we've got pouring water in a cup, adding tea bag, removing tea bag, and we've got two decisions there. Then we've got process, adding sugar, and then we've got the milk, whether we add milk or not, stir and enjoy, and then we stop the algorithm. So here is a flowchart for making tea. I want you to think about how we can break this up into further subsystems. So just the processes, just these purple rectangles, how can you break these up, and what would they contain? What steps would they contain if you was to break these processes up into further subsystems? Okay, I'm going to pause the video and then come back to me in a minute once you've done that task. Okay, so we've had a go at that. So some of you may have looked at boiling water. Now the idea of, I'm going to use boiling water as an example. So when we go into boiling water, we firstly have to ensure that we place the water in the kettle. In the first place, we have plugged in the kettle, the kettle is switched on, we need to make sure we've got the water from the tap. So there's many different steps we need to take to even boil the water. So moving on from there, some of the common flowchart symbols, something that we've done in Key Stage 3, we've already looked at the start and the end, or the terminators box. We've got the process where something is actually happening. We've got the decision where you have a choice, either yes or no. It's normally containing a question, and then you've got the output and input box, okay, where you want to display an output or have a user input a value into the system. So if we have a look at how we make a cup of tea, using your processes, using the list of items that you would have done in each process, what you need to do is create a detailed flowchart with subsystems, thinking about these labels, but obviously expanding on your flowchart with your different steps in each process, with your subsystems involved. So if you pause the video now and have a go at creating a more detailed flowchart with your subsystems included. Okay, so once we've done that, so we're going to look at creating a flowchart. So we've got a given scenario, and we think about how we can actually solve this. Okay, so a town contains 5,000 houses, and each house owner must pay tax based on the value of the house. Houses over 200,000 pay 2%. Houses over 100,000 pay 1.5%. And houses over $50,000 pay 1% of their value in tax, and everyone else pay no tax. So what you need to do, write an algorithm to solve this in the form of a flowchart. Remember, you need to break apart your flowchart into subsystems, into smaller chunks. How is it that we can actually solve this problem? Well, this is a typical exam question. What we need to think about is, what is it that is coming into the system? What is it that we're processing, and what is coming out of the system. So in terms of what is coming into the system, the value. So we're going to have within our flowchart an input of how we might input the value of the. So the house, the value of the house would obviously need to go into a variable. Once you're at that stage, you need to think about what kind of questions your flowchart might ask. Hint, hint. So you need to think about that. Think about how the name of the variable that you might store the tax in. Another hint there. Once that is all done, your flowchart needs to have an output to display the tax, or the total tax that the person has to pay. So if you pause the video and have a go at the exam style question, and you've got 15 minutes to solve that. Okay, so the solution of that task, well, there's no right or wrong way. There's many different ways you could actually do this task. So your first way, the example that I'm going to show you, is as you're developing your flowchart, you would firstly obviously have the input. So you input the price of the house. you have your three questions. Is the house price larger than $200,000? Well, if it is, then you add 0.02 to a variable called tax. And if it's not, then is it larger than $100,000? So it says a million. It's wrong. It should say 100,000. Then you would add 0.015. Is the house greater than 50,000? Then you would add 0.01. And as you're doing that, you would print the tax at that point, and then add a count variable. So I would do it. So you add a count variable, and then because the count is less than 50,000, you would carry the count on until it reaches 50,000. So the count reaches 50,000. Okay. So you're paying tax on that property. Yeah. So there is the algorithm for working out the tax for prices for different house prices. Yeah. So carrying on, how can we solve this? Well, we write an algorithm in the form of a flowchart. Which takes temperatures or temperature input over a 100-day period. So it's working out what the temperature is every single day over a 100-day period, once per day, and outputs the number of days when the temperature was below 20 degrees. Okay, so when the temperature is below 20 degrees, it will create a variable for those number of days. And it will also output the number of days that the temperature was above 20 degrees and equal to 20 degrees, so 20 degrees and above. And you've got 15 minutes to do this. Okay, so how can you solve that in the form of a flowchart? So if you pause the video and have a go at that task. So in terms of working out the temperature per day, and giving us the number of days that the temperature was below 20 and the number of days where the temperature is 20 and above, this is one of the solutions that you may have come up with. Obviously this isn't the only way that you could solve this problem, but yeah, let's have a look. So initially we need to have three variables. We've got count, which would set up 1 because it's the first time around the flowchart. We've got total 1 and total 2. Total 1 being the temperature or the number of days where the temperature is below 20. And total 2 is the number of days where the temperature is above 20 and equal to 20. So we've got the input box there where we input the temperature. Then we have the decision where the question is asked. Okay, is the temperature less than 20 degrees? And if it is, it adds a 1 to the variable total 1, which holds the number of days where the temperature is below 20. Okay, and it will keep doing that. If it isn't below 20, in other words, it's above 19, which includes 20 and above, we would add a count to total 2, which is the number of days where the temperature is 20 degrees and above. And as we're going around the system, the count will increase. So the first time round it's count 1, then once we get to here we add 1 to the count. The count will remain, will keep going, or the loop will keep going until the count is 101, okay, in terms of the 100th one through. So once we've got 100 days of data, we can exit the loop and we can output the total for the number of days where the temperature was below 20 degrees, and we can output the number of days where the temperature was 20 degrees and above, and that will end that algorithm. Okay, so thank you for listening. This is my first video. This is lesson 1 and lesson 2. It's a 2-hour lesson for problem solving. I hope you enjoyed it. I know I certainly did. So this is practical problem solving and programming lesson 1. Thank you for listening. Make sure you like and subscribe.